In this problem, we're asked to compute the antiderivative of x cubed minus x plus 1. And every one of these things is a power function because I could put x to the 0 on that last term. So we use the power rule for all three of these terms. And just as a quick reminder, remember an integral with no limits on it just means give me the antiderivative. And the way this turned out was x to the n plus 1 over n plus 1. And if I'm being totally general, there should be an arbitrary constant there. So why is this the rule for the antiderivative of a power function? Prove it to yourself by differentiating. So certainly the derivative of the constant is going to give me 0, so I'm not concerned with that part. But the power function part, I would bring down the exponent out in front. So I have a 1 over n plus 1, and I'm going to bring down an n plus 1 in front, and then subtract 1 from the existing exponent, which gives me an n. Those n plus 1's cancel, and I get back to what I started with. So this is indeed the most general thing that I differentiate to get x to the n. So I'm going to apply this to all three of these terms. Again, the constant can be thought of as a multiple of x to the 0. And applying the power rule to each of these terms, I add 1 to this exponent on the first term, and then divide by the resulting numbers. That's 1/4 x to the 4th. Then I add 1 to the existing exponent of 1 on the second term. That gives me x squared, and divide by the resulting exponent. So 1/2 x squared. Finally, I have an x to the 0 in that last term, so that goes to x to the 1 divided by 1. In other words, just x. And to be totally general, I should have a plus c on there, and I'm done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.